Welcome to the Cymap mechanical overview video. Here we can see the Cymap interface from a mechanical perspective, and you can see a whole series of programs occupying the top row for the mechanical. The program is very much database driven. All our databases are open source, which allows the user to edit and create their own databases, as well as using our imported manufacturer's datasets. There's also a selection of minor programs as well. So let's go and have a look at the various programs. First of all, the building program. Via an intuitive wizard, the user can select a range of weather datasets from CIBSI and Met Office data. And if you're linking with SBEM, you can select the building types, having installed the software from the CLG. Floor plans can be set up by creating elevations and layering the floor plans on top of each other to create the building model. Template profiles can be set up with all engineering data, and templates can also be imported either from NCM weather datasets from our extensive database or from previous projects. Lighting controls can also be incorporated should the engineer be required to do Part L or Lenny calculations. Rooms can be digitised by hand by the user using the 2D floor plan as the backdrop. Faces can be selected where windows or any other element within a wall can be applied. And ceiling grid arrangements can also be applied in line with the architect or the user preference, where they can be positioned manually, tile centre at room centre or to intersection at room centre with a tile of any size. Rooms can also be copied both within the floor plan or can be copied upstairs between floors. So selecting the floors enables the user to copy floors quite easily. 3D GBXML geometry can be imported from any 3D architectural software that produces GBXML to then populate the floor plans with all the room information. Using a room editor, template profiles can easily be applied to the spaces imported from the GBXML geometry. Ceiling grid information can also be applied on a group of rooms based on zones or by merely selecting from a room list, to save the engineer having to go into each space individually each time to create the ceiling tile arrangements. On setting up a project, the user gets an extensive range of building constructions, historically and to the latest building regulations. Glazing can also be considered, with all the technical data required to perform glazing calculations, including the visible light transmission that can be utilised for daylighting calculations. Composite constructions can be created to calculate the U value and ascertain interstitial condensation and where it occurs, based on a whole range of single materials from an extensive range, based on categories, which are then layered to form the composite. Once the layering is being created and completed, the U value can then be ascertained and can be easily edited with changes in not only the materials but the dimensions, the effects seen in the results. All information calculated to BS 6946 can then be passed across to the list of elements associated with the project. Existing elements that have already been used on the projects can be swapped out for the new material that has just been created. By selecting the material being changed, you simply specify the material that you are changing to. You can apply also a room filter based on floors, profiles or levels. Shading calculations can be applied by setting up the site plan for the building model so that shading can look at various hours of the day, various months of the year. Elevational shading can also be applied so the user can see how the shadows are cast across each face, and this of course will affect all the simultaneous loadings on the building in terms of cooling. Existing floor plans can be manipulated very easily, whether the elevations need to change, whether the user needs to make changes to ceiling heights, or the introduction of revised floor plans as the project changes is a very simple task. Next is the energy program, where we can calculate all our heat gains and heat losses. Based on plant modelling arrangements, we can decide whether we wish to pre-heat, cool or preheat the air to the space, to isolate the fresh air requirement to the central air handling plant via distribution ductwork should we be required to do so. Rooms can be selected and heat gains can be displayed. Rooms can be displayed from a numeric report, linear or bar charts. And predicted summertime temperatures can be also calculated on that basis. Room heat losses can also be calculated as a general listing. Each room can then be examined in detail, giving the breakdown of the losses across each partition based on the automatic allocation of the temperature differential across all of the partitions internally and externally to give the resulting heat loss or heat gain to a space relative to the space the engineer is looking at. Underfloor heat losses can also be undertaken to allow the engineer to look at the viability of whether to use the underfloor heating as the prime heat source or as a secondary heat source based on the provision of heated fresh air to the space. This can then be supplied to the contractor to enable the engineer to size the pipework to the manifolds to the space. There are also links to the standard government SBEM tool. Basically the geometry and all the building materials are exported into the standard tool provided by the government, which you can install. You can then apply that as you would normally. By selecting a range of spaces with their HVAC requirements, the engineer populates the SBEM with the type of system from each separate entry. Where zoning has been applied, for example these 4 spaces have been applied to zone number 2, simultaneous gains to those spaces can be applied. Then a fan core unit can be inserted to service each of these areas via distribution ductwork. Energy consumption calculations can also be performed using steady-state algorithms. If there's a requirement on the project to import dynamic simulated hourly weather data from TAS, this can easily be done by just using the TAS interface, selecting the TAS project, and then applying the preview, and that gives all the cooling and heating loads and volume flow rate requirements which Cymap can then use downstream to size all of the plant, duct, pipe sizes, etc. You then import, and that Cymap now uses those results. You can refer back to the standard steady state CIBSE Guide A calculations if you wish, so the program is flexible enough to allow you to toggle between either dynamic simulation or steady state calculations with no major commitment either way. The piping program can be used to determine pipe runs for LPHW and LTHW systems, wet systems and chilled water systems. This enables the engineer to select radiators or generic items of plant such as fan core units, etc., route all the pipe work back to a plant room, quantify pipe runs, calculate the pipe sizes and determine all the pressures required for pump sizing. Based on the heat losses to the space, the user can effectively place radiators, determined by the windows if necessary. The engineer can then route the pipework on the floor plan, up or down through the building via riser positions, to a position in a plant room where the engineer can connect headers, boilers, and add symbol libraries represent pumps and valves. Any item that requires electrical information can be applied. Electrical details can be entered and then cross-referenced to the Electrics program, where the electrical engineers can then add all the electrical loadings to distribution boards with a view to creating a fully working wiring schematic. Pump duty requirements on a system by system can be ascertained, as can changes be made to each separate system by applying varying engineering selection rules for the piping materials, fittings, insulation and pipe types. The engineer can use multiple pipe types and fluid characteristics. Complete schedules can be displayed on the screen. Or as a complete bill of quantities, where all the services are quantified and prices can be added into the database. Generic heat exchangers, fan coil units can be applied, either servicing the space that they're positioned in, or from a listing of rooms, the engineer can determine the room space the fan coil unit will service. Also, items of plant can be entered, so for example boilers, pumps, etc., with all the relevant data in terms of dimensions, manufacturer's information and electrical details. If combination or domestic boilers are being used, we can provide an extensive range of data from a database to enable the engineer to size the appropriate boiler. Basic 3D schematics can be determined and created based on the inputs from the plans, which allow the engineer to annotate with commissioning data. All reports can be previewed and printed with all the design data necessary to complete the project. The ducting program allows the engineer to size duct runs for supply and extract systems. The software uses a detailed database of ducts in accordance with DW144. Grill positions can be ascertained and placed on the layout based on the requirements for the space, and you can also look at other services. In this case we can see the coordination between the lighting and the grills. Results for ductwork can be determined by selecting, having performed a calculation, each duct run. Decisions can be made, and if necessary, duct sizes can be fixed, or shapes and sizes can be changed. Fan duties can also be determined for each separate system. And full reports can be created as either a print preview or a paper printout. The Public Health Program allows the engineer to determine all hot and cold water and gas pipe sizing. From a symbol library, the user simply places their appliances on the layout and then interconnects the pipework, in this case a cold system with a distribution pipe. The user then taps into the pipe they're connecting into and then display calculates the pipe sizes. Results can be determined simply by interrogating the pipe with a single click. Schedules can also be determined for the draw-offs and the pipes, with all the data necessary to perform the calculations. The Psychometrics program allows the engineer to build up a schematic layout to represent a plant system. This then allows them to determine all the psychometric properties of air based on the prevailing conditions around that system. The user simply sets up a system on a grid by applying these standard symbols and arranges them in the correct format. The user then selects the various positions around the system and enters the data to form the psychometric cycle on the chart. The user can also monitor, for example, in this case, the return air percentage. This allows the user to monitor the cooling and heating loads as a result of the changes they're making. Further information to the psychometric properties of the air around the system can be displayed on a point-by-point basis with full printout reports reflecting the system.